It'll be less memorization. It'll be more understanding concept that'll help you get why things happen as opposed to just memorizing, okay? Got a fraction. In example 1. And a fraction is considered to be a ratio, right? Now here's what makes this a rational function. It's a rational function because I have a fraction with variables. Johanna, got that? You sure? A fraction with variables makes a rational function. Cool? Okay. Now, as soon as I tell you that I have a fraction with variables in it, that should sort of ring some bells, because there are some rules about fractions that we know to be true. One of those rules is that what? I can't have a 0 where? In the denominator, right? The bottom of a fraction can never equal 0. That's a rule. We all agree with that? Okay. What about the numerator? Can the numerator of a fraction equal 0? Yeah, what's 0 divided by any number? 0, absolutely, right? Thank you. Okay. And so those two things are important to understand, right? Okay. So here I give you x plus 6 over x minus 3, and I'm gonna walk you guys through a series of questions now that are gonna sort of outline what I just talked about. But the first of which I didn't. Okay. How do I find the y-intercept of something? Well, y'all agree that a y-intercept is somewhere along there, right? What's the x value anywhere along the y-axis? I'm going to say it again. What's the x value anywhere along the y-axis? 0, right? So to get a y-intercept, bless you, I always plug in x equals 0. So I want to find f of 0. So that gives me 6 over negative 3, negative 2. We go with that? All right, so that's something we've seen before. Next, determine the x-intercept. What's another word for x-intercept? I heard this, I heard this. Both correct, right? Both correct. Okay, now, guys, anytime I have a fraction, so there's a fraction, right? The numerator divided by the denominator. In order for that to equal 0, what has to be true? There's only one way that that can be true, and that's when what? Is when the numerator equals 0. So, in this example, what is the numerator? X plus 6. Subtract the 6. And I get x equals negative 6. Is that how I should write a root, guys? Do we write a root as x equals negative 6? No, we write a root as a coordinate point, right? So what is the root? Or the x-intercept? It's negative 6 comma 0. Okay, next one. Ready? When is a fraction undefined? We said that a fraction is undefined when so the numerator divided by the denominator is undefined when the denominator equals 0. Because why? We're never allowed to have the denominator equal 0. And so if it does, the function is undefined, right? Undefined. All right, so in this case, it's x plus, or x minus 3, right? So I get x equals 3. But hang on a minute, time out. Time out, hold the phones. Brianna, question. Is a root going to be the same as where a function is undefined? No, right? I mean, a root is a coordinate point, right? It's a spot where a parabola, a function, some sort of graph crosses the x-axis. We all agree with that? So what does undefined mean? What does that mean? It can never, ever, ever, ever what? Equal that value. Agreed? Right? So this fraction, or this function right here, will exist everywhere except when x equals what? 3. So what that's going to create, guys, is called a vertical asymptote. Let's write that down. This is going to create a vertical asymptote. What's an asymptote? What's an asymptote? You guys have already talked about asymptotes a little bit. Okay, ready? Here's an asymptote. It's a vertical line that I can get near to, but never what? Never touch, right? So I can approach it, I can get close to it, I can get infinitely close to it, I just can't ever touch it, okay? And so we're going to see what this function looks like and how that plays into the whole thing in a minute. State the domain. Guys, am I allowed to plug 1 into this function? Am I allowed to? Yeah, am I allowed to plug in 5? How about -8? Yeah, how about -6? Is -6 okay? Yeah, because that gives me a what? A root. Am I allowed to plug in 3? No. So I can plug in, ready? The domain is going to be all reals with the exception that x cannot equal 3. Right? All reals with the exception that x cannot equal 3. All right, so what am I going to ask you guys to do with a problem like this, besides what I just showed you? Well, the first thing is take all that information that we just gathered and create a graph out of it, right? So if we look back at that previous page, what did we determine in part A? We determined that this had a y-intercept of -2. All right, so on my graph, I'm going to put a y-intercept at -2. Give me something else that we know. In part B, we determined the root was -6. Okay, cool. What did we determine in part C? All I gotta do is read it. Yeah, that idea of a vertical asymptote. Guys, what does a vertical something look like? Right? So where am I going to have a vertical something? At 3, right? At 3. So I'm going to go to 3. And the way that we're going to create this is we're simply going to draw a vertical dotted line. And what this is going to be is a boundary. That's your vertical asymptote, okay? That's your vertical asymptote. So I'm just going to kind of label all this stuff, guys, so that when you go back and look at it, you'll know what everything is. All right, so there's a root, there's a y-intercept, there's a vertical asymptote. All right, cool. Guys, we agree that there's going to be some function that's going to go through this, right? Did I draw the actual function? Did I draw the graph? No, right? But we have some pieces that we can use to at least get an idea of what this graph might look like. Okay, and we'll talk more about that in the coming days. Right, go down here. Algebraically determine where this function is undefined, give me the domain, and find any vertical asymptotes. Okay, well, undefined and vertical asymptotes, don't those basically create the same exact numbers, right? And hey guys, isn't the domain going to include everything except for what I get for the vertical asymptotes? Fair to say? So what do I need to do here, guys? In order to determine where these three things happen, it's when the denominator equals 0. So it's when 2x squared plus 11x minus 6 equals 0. And you get a problem like this, right? And so immediately you start to say, aha, Picardo, this guy's pretty smart. This is why he had me spend yesterday practicing how to factor something like this, right? What kind of a problem is this? I have three terms, right? So it's a trinomial. This term is a 2, so it's a, well, it could be a split the middle or it could be an AC method, right? You could do it either way, okay? So I take A and C and I multiply them and I get negative 12. So I need two numbers that multiply to be negative 12 that when added together give me positive 11. And those numbers are 12 and negative 1. So what do we do with those numbers? Well, there's my plus 12. There's my negative 1. My question for you is what goes in front? The 2x, right? Whatever this is. And then using the AC method, I have one final step, and that's to take out a 2, right? And so if I take out a 2, what do I get? X plus 6 times 2x minus 1. X plus 6 times 2x minus 1. Now, these are equal to 0, right? So what do I need to do? Take both of these factors and set them equal to 0. All right, so I have a solution of negative 6. Now, hang on a minute, time out. I use the word solution very sort of loosely because it's a solution to that quadratic, but we have to interpret it within the context of what we're trying to accomplish, right? And we'll talk about that in one moment. Plus 1 and divide by 2. So I have these two solutions to the quadratic, But the solutions to the quadratic are really what? Where this has vertical asymptotes. Where this function is undefined. Where this function has exclusions from the domain. So they are anything but solutions to the problem, right? They're actually the things that can never be solutions to the problem, right? Because what did I do? Set the denominator equal to 0. And what do we know about denominators equal to 0? That's always been bad in math, right? Good. So I have vertical asymptotes of x equals -6 and 1/2. This is undefined at those values. And the domain is what? All reals with the exception that x cannot equal -6 and 1/2. Feeling okay about this so far, right? So what did I say? I said you can either memorize a whole bunch of stuff or you can understand the fact that fractions are undefined when the denominator equals 0. And if that's the case, those are exclusions from a graph. Those are exclusions from a domain. That's where a function does not exist. All right. This is actually a good problem, guys, because it's a review of something that we did earlier this year, right? It's called the composition, right? It's a function within a function. Well, what do I happen to have here? I happen to have parentheses, right? And mathematically speaking, we should always do what's inside first. So if I asked you guys to evaluate that, you would find g of -2 first. And g of -2 is equal to -8, correct? And then what do I do with the -8? I take that and I go back and plug it in, right? So what am I finding now? Now I'm finding f of -8, the thing that I'm plugging in, right? All right, so now I got to go to this function and plug in, right? So that's going to be 2 times -8 plus 1 over -8 plus 5. That gives me -16 plus 1 is -15 over -3 or 5. How's that, okay? All right. What's the difference with this one? What's the difference with this one? Inside the parentheses is g of x, right? Is there a number to plug in? No. So what do I need to do? I need to take g of x and plug it into f, right? What does that mean? Well, what is g of x? It's this, right? So I'm going to plug that into the other function. Well, if I plug that into the other function, what does that mean? It means replace all the x's with 3x minus 2. So this and this become 3x minus 2. So what do I get? I get 2 times, okay, so this is going to take the place of this and this, right? So I have 2 times 3x minus 2 plus 1 over 3x minus 2 plus 5. Everybody cool with what I just did right there? What is this going to give me? It's going to give me 6x minus 4 plus 1 6x minus 3. Over 3x plus 3. Now we'll talk about why I did that and what that example is important for in a few minutes, okay? So hold on to the phones. Don't get too excited, Aiden, okay? This is big news. Big news. Good so far? All right. This is another really, really important, guys, review problem for stuff that we're going to do in this section, okay? When I say the word inverse, 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 right? Remember, when you hear this phrase, inverse, the thought that you should have is to switch x and y, right? So if you go back to our function unit, right, we talked about inverses, and the thing that I had you guys remember was, okay, well, with an inverse, the x becomes the y becomes the x. They swap positions. Cool? So in this case right here, if I told you guys to find the inverse, is there a y in the problem? Are there x's in the problem? So what am I going to do? I'm literally going to swap them out. So the y becomes an x, the x becomes a y. Cool? Now we got one issue here. The issue is that we want to solve for y, right? I'm going to put this x over 1. Is that cool? How do I solve a fraction equals a fraction? I butterfly it, right? I do this and I do this, right? So I do y times 1 equals x times y minus 2. What do you think I'm going to do next? Give me a step that you think I'm probably going to take. It's okay to be wrong. Got to solve for y. Give me something I can do, Mo. Come on, you're like the coolest kids ever. Like, participate, please. Like, give me something here. Just give me something. I don't care. If it's wrong, it's wrong. Take the x and square. You want to square root? Distribute it. I love it. All right, because this is a tough problem to actually solve for y. It's not an easy one. That's why I want you guys to try to think about ways that you can do it. Now, if I'm trying to solve for y, what does that mean? It means get all the y's on one side and get everything else on the other, right? So give me a step. Subtract the xy. And I get that. All right, again, I got all the y's on one side, right? But the problem is that x is over there with it. Give me a step. What's something I could try to do here? This is the toughest step of the whole problem. You want to divide by x, you said? Okay, so I like that, but here's the thing. If I divide by x, I have to divide this, this, and this, which is going to wind up leaving an x over here, isn't it? Think of a different step. Think of factoring. What do both of these have? So can I take a GCF out of these two terms? If I take a y out, what do I get? I get 1 minus x, right? You see what I just did right there? I took a GCF out of these two terms. Why is that cool? Because now I only have one y. What's that y doing? It's multiplying, right? So to get y alone, I just need to divide by 1 minus x, right? So there's your inverse, right? There's your inverse. Guys, those were two important skills that we'll review, right? Compositions and inverses, right? Inverse is swapping the x and the y, okay? Compositions is when one function's placed within another function, okay? And we're going to use those within this unit a little bit. All right, last thing I want to review. All right, again, this is going to be part of our unit. That's why I'm reviewing it, okay? It's not new, it's review. Even and odd, okay? For a function to be even, actually, it's got it down here. Sorry. When a function is even, you have symmetry across the y-axis. So in other words, this would be an even function. This would be an even function. Okay? Why are they even functions? Because they look the same on both sides of the y-axis. Is that cool? Okay? A function is, oh, by the way, here's the other, that's the visual view of it, right, guys? That's how it looks. The algebraic view is this. If I have a point x comma y, so let's suppose this point right here is xy. Then there's a point on the other side of it, right? What's that point? Negative x, y. Do you guys agree that the y position is the same? It's the opposite x position, right? So if you have a point xy, then you have a point negative xy. So what did I do right there? I looked at the opposite input and got the same output. Is that making sense? Okay. An odd function. All right, so this is all even. An odd function is one that looks like this. It has point symmetry to the origin. It's a reflection in the origin, Brandon. A reflection in the origin. And the way that I told you to remember this is if your paper looks, or if your function looks the same upside down as it does right side up. If it looks identical, right, and it goes through the point 0, 0, has to go through this point, guys, to be odd. Okay? Then you have an odd function. So does that look the same upside down and right side up? It does. And here's your rule. If you have a point negative xy, oh, sorry, hang on a minute. If you have a point xy, then you must also have a point negative x, negative y. In other words, I have the opposite for both the input and the output. Okay, so that's a review of even and odd, right? Even functions symmetric to the y-axis, odd functions symmetric to the origin. There's your two rules. Cool? So here's what I want to figure out. Is this function even or odd? Is this function even or odd? Or I guess it could be what? Neither, right? Not every function is even or odd, right? So it could be neither. Give me some ways that I could do this. Well, could I test? Could I test a point? Seem reasonable, right? I could test a point. I could plug in 1 and see what I get, and then plug in negative 1 and see what I get. All right, let's do that. If I plug in 1, I get negative 7/4. Everybody agree with that? Cool. So what do I want to compare that to? I want to see what happens when I plug in the opposite. Well, if I plug in the opposite, I get 1 minus 8, which is negative 7, over negative 4, positive 7/4. So let's see if you understood the difference between even and odd. I plugged in 1 and I got a negative. I plugged in negative 1 and I got a positive. Did I get the same output? No, I got the opposite output, right? So with an even function, I should get the same. With an odd function, I should get the opposite. So by doing this, I think I have a pretty good idea that this is going to be a what? An odd function. But here's the problem. Here's the problem. It works for this point. Does it work for every other point? I don't know. So here's what I'm going to do. Instead of looking at f of x, I'm going to look at f of negative x. So what am I going to do? I'm going to replace all my x's with negative x's. How's that sound? So what am I going to do? I'm going to have negative x squared minus 8 over 4 times negative x. What's negative x squared the same as? What's negative x times negative x? X squared over negative 4x. Hey guys, look at the function. This I got x squared minus 8, right? That was the same as this, right? But then I got 4x and I got negative 4x. So what does that mean? That means that if I get a value here, I'm going to get the same value here, except this value is going to be negative. Why? Because this was a negative 4 instead of a positive 4. So this is definitely an odd function. Based on your answer, what type of symmetry must this have? This has symmetry to the point symmetry to the stupid computer. To the 0.00. And that, my friends, is where this first lesson finishes, right? A little bit of review of some topics